Hi guys, now I'm going to present you a scenario where all those IoT devices that are not able to update the server certificate, okay, or maybe are not able to fetch a new certificate via this old encryption link that is still not expired. Those IoT devices would choose this link, okay, and this server will send a 30 days prior notice to all IoT devices, and if all those IoT devices that are not able to update 30 days prior to the date of expiry, it would choose this path, because ultimately this path would be invalidated. So how an IoT device would communicate with the Renew server? The IoT device would store a server cell sign certificate of this server, and same goes that the Renew server will store IoT device certificate that is cell signed by the company that is providing the IoT solution. So first, the IoT device will send a handshake and a client ID, and this Renew server will go through this client ID and all the client credentials over here, and it will see whether to further proceed with the handshake or not. Let's say it proceeds, and it will send a server cell sign certificate, and it will request the client, that is the IoT device, to send its certificate. Okay. Now, after having this, it will validate whether the given cell sign certificate of the server is validated or not. If it is not, it will terminate. If it is, then it would continue with the communication link. Now, the IoT device validated the server certificate, and now it will send uh, its certificate through this link, but it would be encrypted with the public key of the server. Now, this server will take the already stored IoT device certificate, and it will validate whether this certificate and the certificate that this client has sent is okay or not. If it is not, it will terminate this request. And if it is okay, then it will send a symmetric key exchange messaging where they will share a symmetric key, and like encrypted path would be established between IoT device and Renew server. Now the IoT device can uh, message the Renew server for the new certificate of the server of this server. Okay, so this is how it is done. Now all the communication that has been done in this slide is after TLS handshake that has been previously done. So all this communication that has been done here will be encrypted. All the protocol thing, all the application protocol things will be encrypted, so hacker won't be able to see. Now the IoT device sends a new certificate request to the Renew server messaging broker. Now the messaging broker will send the new certificate, and in this way the IoT device would again establish a path to this server using a new certificate. Okay. Now the main challenge here is that the IoT device has sent a, cell sign certificate. Okay, the IoT device cell sign certificate over this link. Now it may happen that the hacker may continuously trigger, or some things may happen. So we aren't taking any risk. We will initiate a new IoT device cell sign certificate request to the main server. Now the main server will contact the IoT device, and that IoT device has to update its IoT device certificate. If it does not updates its certificate, then we will blacklist that IoT device. Okay, because we know that a hacker is trying to hack the network. Okay, so as you can see, if the hacker acting as block access of the IoT device, if the hacker is acting like a IoT device, then this would validate, this would keep a check on the activity of the network. If after subscription to the new certificate request, end to Slack updates is not sent within 1 day, the IoT device is blacklisted. Okay. Now what happens is, if this hacker is acting like this IoT device, and if this hacker is acting like this IoT device, this will there is a bound on the server that the IoT device over here has to send a uh, renewal end request to the main server. Now, if it does not send a request to the main server, then we are pretty much sure that a hacker has hacked or has checked or has looked into uh, the protocol over here. And so we will change the whole scenario over here. If it didn't happen, it will blacklist and it will form an alert on the system. Okay. And the IoT device over here, it will keep the previous state. If it is going through an updation cycle, it will keep the previous state of the machine, so that after connecting to the messaging broker, it will see what all the current state of the system is. So IoT blacklist scenarios: if after subscription to new certificate request, end to lag update status is not sent within 1 day to the main server, the IoT device is blacklisted. Okay. If after 31st day of issuing a certificate update request, IoT device is not able to get certificate from renew server, then that IoT device is blacklisted, which means that if a request has been sent and if a request has been sent and still the IoT device is not able to update the certificate, then it means that some hacker is blocking this certificate to this IoT device. So what we'll do, we will blacklist this IoT device. Okay, blacklist this IoT device, completely blacklist, because there may be some hackers standing over here that is sending that is blocking this certificate to this IoT device. So this is how the blacklist mechanism will work. Now I will discuss these two last slides on the next video. Thank you.